In this chapter, we're going to cover something which isn't actually Spark specific. It's, in fact, a concept from Scala, but it's something that's used so commonly in Spark that I think you'll want to know about it. So, welcome to the world of tuples. So yeah, what's a tuple? Well, as usual, let's start with a motivating example. I know that the work we've been doing so far on this course is just a sort of scratch sandpit really, where we've been playing. We've been doing things like loading integers and square rooting them and so on. But I think what we have here will be sufficient to illustrate the concept of a tuple. Let's say that we have the requirement for some reason to store these integers exactly as we've been doing here in this RDD. But we also need to store their corresponding square roots. So we need both sets of data. Well, we've kind of already got that. If I just remove a few lines that aren't necessary for this example, we can get rid of this line here where we were doing the summation of the input RDD. And here I was printing out the square roots, and here I was printing out some kind of a result. And I think this thing at the bottom was where I was demonstrating how to count elements in an RDD using the MapReduce trick. Let's get rid of all of that. So at this point we have two RDDs, one containing the input data. In fact, let's rename this. Let's call this the original integers. I'll need to change there as well. So we have an RDD of the original integers and the square roots. So there's nothing wrong with that really, but as we're going to discover later, when we're doing more complex operations, we're going to generally want to keep the data together into some kind of coherent record. Now, it's hard for me to explain this until we've gone further with Spark and we've done some more complex requirements, but keeping these two pieces of data, if you like, in two separate RDDs is going to be really awkward to do anything useful with them. What we really want to do is to keep the two pieces of data together. We want to keep an integer and its corresponding square root in the same row, if you like. Well, I didn't explain that very well, so let's look at a picture instead. This is the state of play as we have things at the moment. We have two separate RDDs, one with some integers and one with their corresponding square roots. Now, what I was trying to say really was that it's going to be very difficult to do anything useful with these two separate data sets. We're going to want to do things like grouping. Let's say we wanted to find out the sum of all of the square roots where the input value is greater than 20. Hopefully you get the idea. Now, by having these two completely separate RDDs, I can't imagine how we're going to work. What I'm kind of getting at is that it would be nice if we could have the data all in one single RDD. Something like this. This is beginning to feel like perhaps a Java map or a relational database table, if you think of things like that. But I'm really just getting across here that it would be nice if we could have the values inside the RDD as being multiple values rather than a single one. How could we do that? Well, the first answer to that question is dead simple, because this is all regular Java. And what I've possibly not got across so far on this course is that an RDD can contain any type of data, including Java objects. So what we could do, now this is absolutely fine what I'm about to do here, but you'll possibly find that it's not done that often. Of course, it's just Java, so I could create a new class, and that class can represent this pair of values. So I could create a new class called integer with square, for example, and I'll just create an example instance of this integer with square. And we could make it so that this integer with square contains our two values. So we could put the value, let's Let's go for 9 and the square. I actually mean square root, of course, don't I? Integer with square root, 9 and 3. Actually, thinking about it, we don't need to pass in the 3. We could automatically calculate that from the input parameter. Well, of course, this class doesn't exist, so if you can stand this, it might be a little bit boring because it's just very routine Java. I can hover over this, go for the quick fix of creating that class. Just click Finish there. Then back to the main code. We have an error because there's no constructor that takes a single integer. So again, we'll use the quick fix to create that constructor. And then I can create 2 private pieces of data in here. The first will be an int, which is going to be the original number. We'll also have a double for the square root. And then we can initialize this data in here. And we'll set the square root to be math.square root of the original number. So I really hope this is boring you. It's standard Java. We might create get set methods. We might even create some business methods in there, who knows. But the point of all that, what we could do now, I'll remove this line of code where I was just demonstrating creating an instance of it. What we can do after creating our original RDD containing the original integers, we can now change this. At present, this square root RDD only contains the square roots, but we can make it now so that given a value, which will just be one of the raw integers, we can create or we can return a new instance of our integer with square roots, passing in that value. So I hope that makes sense. However, in the Lambda syntax, you don't actually need the keyword return here. In fact, it is a syntax error to use the keyword return here. So you would need to remove that. We have a compile error here, which I hope is obvious what the compile error is because now the type of this RDD will be of type integer with square roots. And now everything compiles. So now we could go forward and we could do further operations such as reducing or filtering, as I'm about to describe later. Now that works absolutely fine. I would say the general pattern is not to do this and instead to use a Scala concept called a tuple.
Find out all about tuples in the next video.